Okay, so since A is a center, okay, and this is 20 degrees, which makes X is going to be equal to 20 degrees. Okay. All right. So, okay. So if that's 20 degrees, then this straight line right here is 180. And 180 minus 20 is going to give me 160. So if this is 160, then this is 160. Okay. Are there any questions about this? Okay, so if you have something at the center, that is going to be the central angle. Okay. All right, so looking at the next one, go ahead and take a moment. Okay, and I want you to draw this onto your paper and give me an example from the image for each kind of segment. All right, so if I have a diameter, remember the definition of a diameter is it goes through the center of the circle. Okay, so the only diameters that I got is BC, okay, or GH.
What about AC?
Okay, well, what
No,
about, okay, good talk. Okay, now a chord that's not a diameter, that means that any line that's going from one point to another on the circle, that is not the diameter, okay, would be E. It's aggressive, okay? What about a radius? All right, shh. What about the radius? Okay, AB, AH, what else?
AG.
AC, AG. Okay. Yes. I personally like to say radius is whatever the center point is to wherever the outside is. That's how I personally do it. Now, is it going to be wrong? No. Okay, looking at the next one. Okay, there's a little bit more reading to do on this one. Okay. Go ahead and take a moment, try that one. Okay, so draw the central angles associated with the highlighted arcs from D to E and B to C. Okay, so from here to here, don't make fun of my straight lines. Here, here, here. How do the measures of the two central angles appear to compare? What do you? They're congruent. Okay, and how do you prove that?
What would you say?
How do you prove that?
Since one of the angles is the central point, that the sides will be equal because it's the radius.
Okay. All right. He said it. Okay, so this is congruent. Okay, and then also all these little lines that I just drew horribly bad are all the radius, and which means that they're all equal. Right? Yes, ma'am. You can rotate it. So on the next question, it says, think about like the transformations and that kind of stuff. Rigid motion is back when you learned in accelerated algebra 1. Rigid motion is like translation, rotation, reflection, but not dilation. Okay, so she's saying that, hey, can you rotate it? Yes, you can. What else can you do?
Translate it.
You yeah, I would reflect. Yeah, I would reflect. I mean, can you move it? Yeah, sure. That, yeah, just let me live my best life. I missed the L. Reflect. Okay. What does this tell you about the measure of the highlighted arcs from D to E and B to C? They're congruent. because they're equidistant from center. Bro, my handwriting's just getting worse as we go along. It's just happening. It's just happening in there. Just let it happen. Just let it happen. Okay, go ahead and tell me each statement. Could it be? Is it must be true? Possibly true? Definitely cannot be true for all of these statements. You're telling me must be true. Okay. Oh, we can do that. That's fine. Okay. All right. So you're gonna tell me must be true with 1, could possibly be true with 2, and definitely can't be true with 3. Okay. So a diameter is a chord. Definitely, possibly, can't be. A diameter is a chord. 1, 2, 3, go.
1.
Oh, okay. I see you. I see you. All right. Y'all said, yeah, fam. Okay. That's what y'all said. Yeah. All right. Just let it happen. Okay. A radius is a chord. All right. You're going to tell me yes, must be true, possibly true, or definitely can't be true. Ready? 1, 2, 3, go. Okay. I see less hands going up. So that's making me worry. But it is no. Nah. Okay. So on the next one, a chord is a diameter. Ready? Go. Oh, I got a mix of 1 and 2s. Okay, so this is gonna be possibly because it can be, but not always, right? So we're gonna call this mayhaps. Yeah. Okay. All right. A central angle measures 90 degrees. Can that happen? It could. Again, mayhaps. Okay. Maybe it can happen. Mayhaps. Okay. It looks like naps. It's fine. All right. Just, again, let me live my life. Okay. Last one. Woo! All right, all right. Who lives in a pineapple under the sea? Okay. Shh. Okay. RPQ. Okay. So RPQ. I would take. You could do 2 different answers for this, but we're gonna talk about this. RPQ. Okay, is gonna be 154, right? Because it's the central angle. With me? Okay. SPQ. Okay. SPQ. Okay, I'm gonna assume that they're talking about this side. However, you could have done this as well because it could be the other side. Because they really didn't define like which direction. But again, we're probably talking about SPQ. Yes, because otherwise this would be called something else. Okay, so SPQ is going to be 86 plus this. Well, in order to figure out what this is, I'm going to take a whole circle, which is 360, subtract 60. That's not 360. Subtract 60 minus 154 minus 86, and that's going to give me 60 for these. Now, in order to figure out what this is, I'm going to take 60 plus 86, and what's that going to give me? 146. Now, if you put 214, I would take it, but just be mindful of that. Okay. Arc ST right here. I'm going to take 60 and divide it by 2. The reason why I'm going to divide it by 2 is because these are equal because they both have one singular line. Okay, so back when you were learning about angles, if it had 2 lines and then the other thing had 1 line, they were not congruent. But since both of these have 1 line, then they're congruent. Does that make sense? So ST is going to equal 30 degrees. Okay. Okay. So what I need you to do, because I think a lot of you are still missing this, if you go into Delta Math, okay, and you go in here, I need you to complete the inscribed angles. Okay, that is due today. That is going in the grade book. Okay, so I'm gonna give you some time in class to work on it. When you come in on Monday, the CFA will be taken. So you'll come in, I'll tell you to put your book bags at the front of the room, cell phone in the book bag. It's like 9 questions. It's not long, but it does tell me, hey, are you getting what I'm telling you? Okay. They're also coming from the county. So really important for you to try your best because that's what your final is gonna look like potentially. Okay. One thing I do want to mention, there's something important that we have already actually talked about, but I just want to make sure that y'all are good on this. So you need your paper and your pencil. So where you're taking notes, hopefully right now. Okay. But I need you to write down these words. Okay. Because they're going to be important. And you're going to want to review this before Monday. Yeah. We're going to take it later because we got the iReady stuff next week. So it'll probably be the week after.
It's gonna be on the first, on this.
Yeah, it'll be on that stuff. Oh my goodness. Okay. All right. Shh. Okay. So what I need you to remember is, you're writing it down. Ready? Okay. So what I need you to know is the ratio. Right. You're writing this down. The ratio of the diameter to the circumference is the same for any circle that's dilated. The ratio of the diameter to the circumference is the same for any circle that is dilated. What is that called? Close. What is it like? It's an actual number that you know. Pi. Yes. Okay. So the ratio of the diameter to the circumference is the same for any circle that is dilated because pi. Does that make sense? Okay. I need you to know that statement. Okay. We've talked about it, but a lot of people struggle with it because we forget words and we do numbers instead of math. Okay, cool. All right. Yep. Yeah. It should be. Yeah. Okay. All right. So what I want you to do is spend some time working on your delta math. Okay. And then we're gonna kind of go from there. Are there any questions for the good of the group? Why? Like you mean like? Yeah. What's up?